In this video clip, we are going to talk about power functions. What's the meaning for a power function? A power function has the form like this: y equals x to the alpha. Here, alpha is a constant, and x is an independent variable. For example, alpha here can be 2. Then in this case, y equals x squared. So this will be a parabola. And we know the graph of y equals x squared. Alpha can also be a different constant. For example, 1/2. Then y will be equal to x to the 1/2, which is radical x. So it's right here. Let's see the graph of this radical function. And here is the graph of the radical function right here. Let's see how did we actually got the graph of this one by looking at the animation of this graph. You know, when do it frame by frame. When x equals 0, you plug in 0 here, radical 0, you get 0. So 0, 0 is here. Okay. 0, 0 is here. Now, when x equals 1, you plug into the equation, you have a radical 1 is 1. So 1, 1, this point is here. That's the second point. Okay, then you do is you choose 2. X equals 2, radical 2 is approximately 1.414. So you have the third point right here. Keep going. X equals 3, radical 3 is approximately 1.732. And then you have the third point right here. X is 3, y is less than 2. 1.7 is less than 2, so it's lower. When x equals 4, plug in 4 here, you get radical 4 is 2. So 4, 2, this point is on the graph. And then you can connect all the points with a smooth line. Then you will get a graph of this function, y equals radical x. Okay, so you may play the animation in this way. See actually how it goes. Okay, all right. Now, what do we need more is from this expression. Not only we need to graph, not only we need to draw the graph, we also need to prove the function is actually an increasing function. For example, here, when x is 1, you have a y is 1. When x is 2, you have a y. When x is 4, you have a y is 2. So x goes bigger from 1 to 4, you have a y goes bigger as well from 1 to 2. We want to prove this general trend. So we need to have a general proof then. And here is the general proof. Look, we choose x1 less than x2 and try to calculate f of x1 minus f of x2. Well, here is x, here is x. Well, here is x1, then here f of x1 needs to be radical x1. Well, here is x2, then f of x2 is radical x2. Okay, now the common way to figure out which one is to figure out if this one is negative or positive is we multiply by the conjugate. Here is minus, so you want to do this plus. The upstairs and downstairs, they are the same, so you know the value you multiplicate is actually value 1. But here is plus, and here is minus. When you do the multiplication, you know the detail steps would be what? Radical x1 times radical x1. So what you get will be x1. Radical x1 times radical x2. So you will have a radical x1, x2. Negative radical x2 times radical x1, so you have a negative x1, x2. Negative radical 2 and times positive radical 2, so you have a negative x2. Those two will be cancelled, okay? Because you know when you multiply, when here is subtraction, here is addition, you know the 2 tens in the middle will be cancelled. That's why you need to multiply by the conjugate of this one, okay, of the whole expression. Now you have a numerator is what? Is x1 minus x2, so you put it here. Okay. Denominator, you keep it. Okay. Then you know you assumed x1 is less than x2. So both sides subtract x2. You know this will be cancelled to 0. But left-hand side is x1 minus x2. This basically tells us this is a negative number. So the whole thing is negative. Denominator here, they are both positives. Alright? So then what do we get is here what we said. You see this one is negative. As we mentioned here, this one is positive. So a negative divided by a positive, of course, is negative. Then this whole thing is negative. It then tells us this expression is negative because they are all equal. Okay, they are all equal. So it tells us that this one is negative. Then, of course, one number minus another number is negative, then that's because this number is bigger than the first number. So then you have that. Okay. Of course, you may do is mathematically add f of x2 on both sides. Okay. And then you may cancel positive negative. So you have f of x1 less than f of x2, this one again. So starting from here, x1 less than x2 ends up here, f of x1 less than f of x2. So you know when x values increasing from x1 to x2, y value also increasing. So in this way, then what you can conclude? You can conclude is that, then we know function f of x is an increasing function on its domain from 0 to positive infinity. Here the domain is from 0 to positive infinity. 0 is included. Why is that? Remember, for the expression here, you cannot put negative number inside. You cannot do that because this is what? This is not defined. Not defined. So any negative number as a radicand cannot be defined. Do you still remember the reason? It's because of what? Because negative 2 squared is positive 4. 2 positive squared is also positive 4. So radical 4 is 2, and the negative radical 4 is negative 2. There is no negative number you can really plug in here. That was the reason. Okay? Alright. Please review this clip. I'll see you next time.